continuing to look through our prelim exam, and today we're doing this one here, numerical solutions of equations, and I've got a suitable pair of graphs showing the equation x to the power of 5 equals 2 plus x has exactly one real root. So to do that, I will just draw a y-axis here. And maybe I'll pop in my x-axis this way. Along here, let's see what we get. Okay. Now, first of all, I'm going to construct this graph here. Crosses at 2 and goes across 1 each time. So this would look like something like this. Right, and we can probably extend that. Oops. We can extend that down this way. Where does it go? All the way down here. Okay. Alright, so that's our y equals 2 plus x graph. So, and I could just put in my, this is 1, 2, you get the idea, 3, 1, 2, 3, minus 1, minus 2, minus 3, and so on. Okay, now I'm going to look at this one here, x to the power of 5. So 1 to the power of 5 is 1, and 2 to the power of 5 is a very big number. What is it, 32? So it's way up there. 0 to the power of 5 is 0. Minus 1 to the power of 5 is minus 1. And then negative 2 to the power of negative 5 is a very big number. So we've got something like this. And then it's going, oh, not even, whoops. So something like, I've got, and then it's going to go up like this very steeply. Okay, so you can see that there's going to be one real root. Okay, so I would write since between x equals 1 and 2, the function x to the power of 5 gets steeper. And it will never, again, cross y equals 2 plus x, and perhaps I could even say, instead of between, since between x equals 1 and 2, I could say since after x equals 1 and before x equals minus 1, the graph function gets steeper and will never again cross. Right, okay, so I think that explains that fairly well. Now the next thing is we have to show that if the sequence of values given by this iterative formula converges, it converges to the equation found above. In other words, this equation here. So what I'm trying to do is show that this gives us x to the power of 5 is equal to 2 plus x. Alright, well that's fairly easy. First of all, I would write what they've given, x equals 4x to the power of 5 plus 2 all over 5x to the power of 4 minus 1. I'm going to times both sides by this 5x to the 4 minus 1, so I'll get 5x to the 5 minus x equals 4x to the 5 plus 2. And then I can go from there, x to the power of 5 minus x equals 2, x to the power of 5 equals 2 plus x, and I've proved that. There's my 2 points. And then the last bit is using the iterative formula with initial value of x1 equals 1.5 to calculate the root to 3 decimal places. So you know how to do this on your calculator. I think everybody got it from this point correct. So all you need to do is type on your calculator on the top of the fraction 4. The first step is to go 1.5 equals, and that becomes the answer stored in your calculator. So then you go type in 4 answer to the power of 5 plus 2 all over 5 answer to the power of 4 minus 1, and then you go equals, and so this gives you your second value, which is, we'll call x2, and I get 1.33. Now make sure you give each iteration to 5 decimal places. So I've got to go 1.33162, and then you just press equals again to get your next one. So I've got x to the x3 is equal to 1.27351. Then I go equals again. x4 equals 1.26724 equals again. So x5 equals 1.26717 equals again. x6 equals 1.26717, and I think we can say, or 1.2, we've got to give our answer correct to 3 decimal points, 267 to 3dp, and that is all that you need to be able to do to get full marks on that one. Alright guys, hope that makes sense. If you've got any questions, as usual, ask me about them in class, or you can comment as well.